The topic of this lecture is the stereospecificity of the E2 mechanism. Just like SN2, the E2 mechanism is concerted and is therefore stereospecific. Let's look at an example. If we try to eliminate this alkyl bromide using a bulky base such as sodium isopropoxide, we get a single stereoisomeric product. This is because the proton that is abstracted and the bromide leaving group must be anti-periplanar in order for the elimination to take place. In order to look at the anti-periplanar nature of these two atoms, we need to use a Newman projection. We will use a Newman projection looking down this bond. This is our Newman projection looking down this bond. And you can see that I've drawn the Newman projection in such a way that the proton and the bromine, that is the leaving group, are anti-periplanar to one another. When the isopropoxide comes in and abstracts the proton, we form a double bond in a concerted fashion, meaning that the methyl groups, which are on the same side of the single bond, are on the same side of the double bond as it forms, giving us a single product that looks like this. I've drawn the product so that the front carbon from the Newman projection is on the bottom and the back carbon from the Newman projection is on the top. We can then translate this product to the compound I've drawn above. And in both of these cases you can see that the methyl group on the back carbon and the ethyl group on the front carbon are trans to one another, just like they are in the original product. This has to do with the bonding overlap that is occurring between the bond to the proton and the bond to the bromide. Those two bonds must be anti-periplanar to one another in order to achieve proper orbital overlap when forming the pi bond. Now let's try another example. What happens when we eliminate this alkyl bromide using isopropoxide? Take a moment and pause the video and see if you can draw the Newman projection and predict the product on your own. Again, we will draw a Newman projection looking down this bond. The Newman projection looks like this, when we have the proton and the bromide anti-periplanar to one another. When we eliminate in a concerted fashion, we end up with a product that looks like this, where the methyl group and the ethyl group are cis to one another. In other words, this product. In cyclohexane systems, both the hydrogen that's being abstracted and the bromine that's leaving must be axial in order to be anti-periplanar. Let's look at an example. If we try to eliminate bromocyclohexane using a bulky base to prevent the substitution reaction, we get cyclohexene. Remember that bromocyclohexane can either be in an equatorial chair conformation or an axial chair conformation. If the bromine is equatorial, if we draw the Newman projections looking down these bonds, we see that there is no proton anti-periplanar to the bromine. However, if the bromine is axial, we see that there is a proton anti-periplanar to the bromine. So elimination can only occur when that leaving group is in an axial conformation and when there is a proton in an axial conformation on a neighboring carbon. Let's look at another example. Again, pause the video now and see if you can use Newman projections to predict what the product of this reaction will be. In order to eliminate, we need to have the bromine axial. So we can draw this molecule in a chair conformation where the bromine is axial. We can either eliminate from the carbon to the right or to the left of the carbon containing the bromine. However, in this case, we cannot eliminate from the carbon to the right, the carbon bearing the methyl group. If we draw a Newman projection down this bond, we see that there is no proton anti-periplanar to the bromine because the methyl is there. Therefore, we cannot eliminate at the carbon bearing the methyl. We can only eliminate from the carbon on the other side of the carbon containing the bromine, where I've drawn in the proton. We can see that this proton is antiperiplanar if we draw a Newman projection looking down these bonds. Here we see that there is a proton antiperiplanar to the bromine, and this can be eliminated. Our base will remove this proton, forming the double bond and kicking off the leaving group to produce the single stereoisomer of the product shown here.